Good morning. Hope you're doing well. So we made a client to a mystery server, but we want to write our own server because we're cool, and I think you're cool. So we're gonna modify a program so that we can either run it as a server or as a client, so that we can test things out for ourselves. So first of all, I want to make like a little selector in the beginning so we can specify if we want to run this program as a server or as a client, all right? So we'll just make one program and, be able to run it in either or. So I'm going to make a little selector in the beginning, and I'm going to use scanf for that. So scanf will just read from the command line. It's like sin if you use that, like SCIN. But yeah, it's the C version. So we're gonna read a string. Gonna make a char buffer for this one. Char selector. Very nice. Alright, so selector, so we're going to provide a pointer to our string, and then we're going to provide how long the string is. I had a take before this one where it was giving me errors and I didn't understand why. And now I realized that the scanf_s, which is required in Visual C, the _s means that if you're reading a string from the command line, then you need to provide the length of the buffer after the char pointer. So that was tripping me up. All right, so now we're reading our selector, and then we're gonna just do a little if statement based on that. So if we, we should print first. It's like what mode? C is client and S is server. Okay. So he's gonna print this out to let you know if you type a C, enter, then we get a client. If you type S, enter, then we get a server. All right, so then we're just gonna do, whoops. So if selector 0, so the first character is C, then we're gonna run client. And if selector 0 is S, then run server. All right, cool. So I'm gonna move all of this stuff, all of the client code, I'm gonna move that into its own function. So I'm just gonna make a void client main. Just move everything in there. There we go. So now since I'm in a void, I just need to modify the return statements here. Remove the 1 there. There we go. So now we have the client code in its own function. So we're just gonna call that from here. So if we type C, then we call it client main. And if we type S, then we want to run a server main. Server main. There we go. And I'm actually gonna move the VSA startup. You know what? I'll just move that to main. Just so, because we gotta have to do that on both of them. So we'll just start up VSA there. Cool, let's see if it works. What mode? Question mark, question mark. So either client or server. So if we type C, then it quits. Great. I don't know if that's good. It's supposed to do things. It's supposed to connect, right? Yeah, let's see what happens. I'm just gonna break here. C. What selector? It's C. So selector 0 should be C. Client main. Where's it quitting? Oh yeah, it's just going by so fast. Okay, right. Alright, so phase 2, control F5. There we go. Client. Okay, cool. So it runs the client code. I forgot that it just does its thing so fast that I didn't even notice. I thought it was just like not doing anything. Okay, great. So let's start up a server then. So a server has 2 jobs. It has a listen socket All right, so let's actually paint this out. Oh god, so bright, so early in the morning. Okay, so here we have our server. So the way a server works in this case is that we'll open up something called a listening socket. All right, and what a listening socket does is it just accepts connections from the outside. So we'll have some client here. Let's just write a little cloud. So that's like, you know, the internet. So a connection comes in through the listen socket. And what that will do is actually spawn a new socket. And this new socket that it spawns will be the one communicating with that computer. So we get an individual socket for that one connection. I can actually write this out with actual computers. So we have clients here. So computer A will connect, and the listen socket will accept that. So the listen socket will say, okay, computer A is trying to connect here. So it will create a socket for us that communicates with A. Fantastic. So now we can talk to A through this socket, and A will communicate with us through this socket that was created. And same thing for B. So B will connect, and the listen socket will accept the connection. And we'll create a new socket for B. So now we have a socket to connect, or not to connect, to talk with B. So the listen socket that we're gonna make isn't actually gonna send and receive any information, at least on our level. It will just listen for connections and then give us sockets when a connection is made, and then we communicate through that socket. So we'll have an individual socket for every connection that is made. So one socket will only ever talk to one other system. So, you know, if we have, 1,000 computers talking to us, eventually we'll have, 1,000 sockets referring to each of those clients. So that is how sockets work in this case. I will say in this case, we're not going to talk about it, but in this case, that's how it works. So let's make a listening socket. So I'm going to make a listen sock. And it's going to be the same settings as we did before. We're going to make an TCP socket. There we go. So again, address family, iNet, internet. Stream sockets, which is another name of making a TCP socket. So we're making a TCP socket. So now we have our listening sockets. And one thing we need to do for this listening socket to actually work is that we need to bind it to a port. Because remember, we have to choose a port for our socket. Because our server might be running a tons of servers. Yes, a whole tons. So it might be like a billion fucking programs going on, all with their own listening socket, listening for connections all the time. And we need to specify that our listening socket is going to accept connections that are trying to be made to port 35,000, for example. 3,500. So that's what we're going to do. We're going to bind our socket to listen to this port. That's what that's called. It's called bind. So we're going to bind our socket to listen to that port. Bind up our listening socket. To do that, we're going to specify a socket address, which is going to be bound, which we're going to bind to. So we're going to do bind address. So just like with the connection here, we're going to set it up in mostly the same way. Sin family, I'm going to have to specify that. Now for address, right? Because remember here, we when we were connecting in the sock address structure, we were entering the IP of where to connect to. But if we're not trying to connect here, we're just trying to bind up our socket to a port. And while you can specify an IP, I'm not actually quite sure what that does. In the end, it doesn't really make any sense. We don't care about the address. We just want to specify a port. So what we can do is actually write in address any. And that means when we're binding up our sockets, it will just pick any address to bind to. And again, I'm not an expert in this. Maybe binding to another address than you're actually on does something well. I don't know, maybe some of you guys know more than me on that front. But as far as, you know, making a simple server goes, we don't want to specify anything. We're just going to type in address any, and we'll just pick the address of our computer. And then comes the port, and this is the port we want to listen to. So I'm actually going to scan that from the console. So I'm just going to write printf, whoa, easy there, Tiger, port, and then scan fs d. It's port. Or actually, I'm going to make this an unsigned short, because that's what the port is actually supposed to be. So we're gonna read an unsigned short from the console, so we can specify which port we actually want to host our server on. I'm pretty sure it's gonna throw an error, but we'll see. So then we're gonna specify that as the port. There we go. Great. Yeah, there we go. So it's being angry at me. The reason is here I put %d, which is read an integer from the console. Of course, we're not having an integer, we have an unsigned short. So the way you write that is you do half, so h, so that's half an integer, right? So instead of 4 bytes, we're just gonna read 2 bytes. And additionally, it's unsigned, so I'm just also gonna put the u there. So HU, and that means half unsigned. So now we're gonna read a half unsigned integer from the console and put that into the port. Into the port. What is it? Listens or holds a value that must be examined. Don't tell me what to do. So let's try and bind this bad boy then. Bind. So binding, we're gonna enter the socket in which to bind. Then we're gonna do the socket address pointer, and we've done this before. We're fucking experts. We know how this works because we've done it before. It's exactly the same like in Connect. So we're just gonna do listen sock. We're gonna bind that one. Then we're gonna bind to bind address, and then we're gonna give it the size of bind address. Again, this is for the typing reason. We're gonna cast that to a sock address. There we go. Yes, again, this is because typing reasons. This is C, not C++. They've chosen to make one struct for each specific type of address that you can make, like IPv4, IPv6. And this bind function accepts any one of those addresses. So now we have a bind, and we're gonna check the result of that actually. So we're gonna do int bind result is equal to that. And same thing as with connect. If it returns 0, then it was successful. If it returns anything else than 0, then it was unsuccessful. So we're just gonna check if bind result. And then we're just gonna printf bind failed. And then we're gonna print out VSA get last error. So in case it fails, we want to get the error code too, so we can examine what kind of went wrong there. Great. So now we bounded. So let's see if it works. So we're gonna mode server port, and then let's say 2500, and then it just quits. So I'm gonna run it in without debugging, so we can actually see the output here. Server 2500. Hey, there we go. So we didn't get a bind failed, so that's good. So we've successfully bound our socket to listen to this port now. Fantastic. Of course, there's one error here that I've written in, and I want to see if you guys can spot the error. Remember when we were connecting, we were having issues a little bit. I don't know if you guys remember why. It's this one. Yeah, so the error is with byte ordering. Since Windows is a little endian, but all network data is always in big endian. Big endian, not big Indian. So we have to call this host to network short to actually swap the endianness of the number. And the same thing goes for the server. So while we are typing in, 25,000 as our port, what's actually going to happen is that we're going to listen to, 2500 swapped, in like with the byte swapped. So that's going to be something else. I can't, you do the math. But we want this to be right, so we're just going to convert that to network NDNS. This is a very easy trip up to do, because it looks like it works, right? It's like, it's not giving an error or anything. It's just that we're listening to the wrong port. Like, or not the wrong port, but not the port that we wanted to listen to. Which is going to cause problems. So we have to just remember to swap around the bytes there. Okay, so now we bound our sockets. What now? Well, now we have to put the socket into listening mode. So now that we created a socket, we bound it, now we want to mark it as you're supposed to be accepting connection requests. And we do that with the accept function. Nope. We do that with the listen function. Listen suck. And now we have a backlog, and that's essentially how many connections can be handled at the same time. So if we have a lot of connections coming in, how many of those can sort of be stored at once as we're taking them in. So I'm going to do 5. It's generally not a big deal which number you choose, because in general, as soon as a connection comes in, you're going to accept it. I'm not sure about this one, but I'm just going to type 5. I like 5. I don't know. Get off me. So now we've set our listening sock into listening mode. So now that we are in listening mode, now we can start accepting connections. And we do that with the accept function. So accept is a blocking function, just like receive and send. It will block, it will block until a connection has been made. So it will, when we call accept, it will just sort of wait there and chill until there is a connection coming in, and then it will return the socket. Remember, because when an accept is made, it creates a new socket for that connection. And as we see, accept returns the socket. So it will wait for a connection to come in, and then it will do its thing, and then return you the socket after that new connection. So we're going to accept on the listen sock. So that's the sock that's doing the accepting, and since listen sock is the one that is in listening mode, that's the one we want to put in. And then we have a pointer to a sock address and a pointer to an address len. And this is just to get the address of whatever is connecting. But this is optional. We don't need to do this. So we're actually going to wait with that a little bit. So I'm just going to type null. You could do null pointer as well. Go nuts. And we're going to save that socket client. There we go. And I just type. We got a connection. Yippee. Cool. What's wrong? I don't understand this fucking warning. Client holds a value that must be examined. It's like, what do you mean? It's something sure. Okay. And a spell checking on it as well. How dare you say yip? It's not a real word. Okay. So let's see what happens if I run this. I'm gonna run in server mode and then 25,000. Okay, so we're getting a firewall, and this is from the listening. You actually have to give it elevation to be able to accept connections, so you don't get, you know, malware on your computer. And there we go. So I accepted the thing, and now we're stuck in accept mode. I think. I hope. So let's actually. I can't break. It's not in debug mode. But since we're not exiting, I'm assuming we're stuck in accept mode now. So now it's just sitting there waiting for a connection to happen. It's just waiting for a friend. So let's give it a friend, shall we? Let's run again. So I'm gonna run the program once more, and I'm gonna run a client. So let's see. I forgot. We need to, yeah, okay, so we need to mod the client a little bit. So the client right now is connecting to my server at home, but we want to be able to connect to our own server. So I'm just gonna hard code this for now. Fucking whatever. I'm just gonna connect to 127.0.0.1, which again is the special localhost IP, which is just referring to yourself. I am gonna enter the port though, so I'm just gonna copy this code here. There we go. So I'm gonna do the same thing here where I enter the port through the console. Just enter that there. And let's, I think we have to shut down the server actually. Is it running one? Yes. Okay. I'll run the server. 25,000. And then client. 25,000. Wow! Look at that. We got a connection. Yippee! So a connection was successfully made. So our client was connecting to localhost. Whoops. So our client was connecting to localhost, and the accept function returned the sockets of the new client. How neat. So let's real quick just remake the functionality we had on the previous server that I made. So in the previous server, you first sent a message, and then the server sent a message back to you. So we're just gonna do that. We're just gonna read. So we're gonna do read buffer. We're gonna read some data from the new client. So we're gonna receive client read buffer. The buffer is 1024 and there's no flags. So we're gonna read something, and then I'm just gonna send back just a static message. Response is I'm new at this. Sorry. And then we're gonna send that to the client. There we go. So let's see if that works. So the client is still set up. It sends a message, sends hey. Oh yeah, we should print it, right? So let's actually print what the client is saying. Printf. The client said that thing. There we go. What the hell? Okay. Let's see. So we start up a server. Port something. 25,000. Start it up again. Client. 25,000. And boom. Okay, so yeah, we need to null terminate the string, obviously. Still have that issue. But hey, the client said hey. How nice. And on the client, we see I received, I'm new at this, sorry. So the response we wanted to send got sent to the client. So the client received a response. Let's just quickly null terminate this actually. Read. Oh yeah, we need to int read len is that, and then read buffer at read len is 0. There we go. I'm doing Control F5 here, by the way, so I can open up multiple instances. So we're gonna start a server. Gonna start up a client. And there we go. Now it looks a little bit more presentable. The client said hey, and the server said I'm new at this, sorry. Great. So one interesting thing we're gonna see here is that if I start up 2 servers, actually, one thing to keep in mind is that I start a server and I bind it to 25,000, right? And then I start up another server and try to bind to 25,000. Bind failed with error code 10048. Let's check out that error. Let's see. I had some websites up. I was watching Tetris. VSA error codes. Yeah. Just put it in bookmarks. What was the error code? 10048. And we get VSA E address in use. The address already in use. So I don't even need to fucking watch this. No, get so opt. I don't want to watch that. I don't even want to read this. The problem is that we can't bind multiple sockets to the same port, right? Because if a connection is coming in, we need to send it to one socket that can accept that connection, right? So it doesn't quite make sense to have 2 sockets bound to the same port, because then because then which one do you choose? Which one handles the connection? So that's why we got a bind failed here, because we tried to bind a port that was already in use. Very naughty. So there we go. Now we have a server and a client. Very nice. So next time we're going to look at having a server that can actually accept more than just one client. And we'll see how that goes. So stay tuned.